All right, guys, so since I couldn't get the Apple TV to work today, we're just going to do our notes for a flip video. I handed you two pieces of paper that you're going to be filling them in. So instead of taking regular Cornell notes and writing everything down, you're only going to have to fill in the blanks. And most of the time, everything that I want you to write will be in red. So we need to go over the difference between elements and compounds. The definition of an element is it cannot be broken down into a simpler substance. An atom is the only particle of an element, where a compound can be broken down because it is made up of two or more different elements that are chemically bounded together. Properties of an element, you can always tell where a property is based on its position of the periodic table. For example, if you were to talk about lithium, because lithium is in group 1 and has one valence electron, you know that it is extremely reactive. So you can predict the properties of potassium and cesium because they are in the same group and have the same number of valence electrons. The properties of a compound, however, when those two atoms bond together and create a new substance, that new substance has completely new properties. We have our examples. And then we know that elements can always be written using the symbol, where compounds will be used writing a chemical formula. Blah. All right, so the difference. An atom is the smallest part of an element. An element is many atoms of the same kind together. And a molecule is any atoms that are chemically bound together. Now, here's where it gets really confusing. A molecule could be like H2. It is two atoms bonded together. So technically, it is considered a molecule. Where a compound is two or more different elements chemically bonded together. So H2O can be considered a molecule or a compound, but H2 is only a molecule. It cannot be a compound because it is only made up of one element, which is hydrogen. And to be a compound, you have to be made up of two or more. So I want you to classify these following elements. Tell me if they're an element, compound, or molecule. So go ahead and pause the video and fill them in. So titanium is an element. Because it is on the periodic table, it is an element. Hydrogen peroxide is a molecule or a compound. Again, that's where I said it gets really weird with the way they are. I would technically say it is a compound because it is made up of two or more different elements. Cl2, molecule, because it's two of the same atom. Na, element, because it's on the periodic table. And NaCl is a compound because it is made up of two different atoms. Okay, so turn your notes over on the back of the first page, and I want you to classify each picture. Tell me, do you think it's an element, a compound, or a molecule? So pause the video and fill it out. Okay, so number 1, if you look at the picture, because they are all the same shape, they're not touching, and they're all the same color, this is an example of an element. Number 2 would be a compound or a molecule. Now notice how they are touching. So that means that it is either a compound or a molecule, but they're made of two different types of elements, and you know that because they're two different colors. So technically, the most accurate would be a compound. And then the last one is a molecule. Again, because they're touching, that represents that they are chemically bound together, but they are the same color, representing the same type of element. So it's not two or more different, it's just one, so it's a molecule. Okay, so let's review on a subscript. We talked about this today in class, but I really want to make sure that you truly understand it. A subscript is when writing a molecule, the symbol for each element will be followed by a subscript. Subscripts will always tell you the actual number of atoms present in a molecule. If one atom of an element is not present, then there will not be a subscript. So remember, we kind of talked about that if you don't see a number, always assume it to be a 1, never a 0. So the subscripts are these tiny little numbers that are written behind an element. So for H2O, it tells us, this subscript is telling us there are 2 atoms of hydrogen and 1 atom of oxygen. And we know it's a 1 because there is no subscript. So again, subscripts are the tiny little numbers, and they tell us the number of atoms. Coefficients are the large numbers that are written in front of a chemical formula, and coefficients always tell us the number of molecules or compounds, again, whichever word you want to pick. So in this example, we have 2H2O. That means there are 2 molecules of water present. So whatever the coefficient is, that is how many molecules or compounds, whichever word they pick, that is it. And again, if you do not see a number, it is always understood to be a 1. All right, so let's identify the following parts. I want you to circle all your subscripts and put a box around all the coefficients, like in this example. So go through for the chemical formulas below, and I want you to put a box around the coefficient and a circle around all the subscripts. So go ahead and pause the video and do that. Okay, so if you do that, this is how your paper should look. Did you get it right? If not, go ahead and fix it. Now let's talk about parentheses. We touched on this at the very end of class, but parentheses, when we're talking about a chemical formula, is just like in math. If an element or a compound are inside of parentheses, then if there is a number or a subscript written outside that parentheses, you're going to apply the distribution all the way to it. So for example, because there's a 2 subscript, this 2 is going to apply to the oxygen and to the hydrogen as a subscript. It is not, however, going to apply to the barium because the barium is not inside the parentheses. So if I was to ask you, how many atoms of barium are there? Well, we don't have a coefficient and we don't have a subscript, so that must mean that it's 1. How many oxygen atoms? We don't, again, have a coefficient, but we do have that subscript, which is 2. And how many hydrogen atoms? Is 2, for a total of 5. Okay, this is on the second page. I want you to go ahead and draw these symbols on the left. Again, shape and color represent different types of elements. If they're touching, that means that they are chemically bonded together. So go ahead and pause the video, draw these down the first column, and then fill out the number of atoms, elements, and molecules for the chart. All right, so for number 1, there should have been 3 atoms, 1 element, and 0 molecules. There are 3 atoms because there are 3 pyramids, or triangles, 1 element because they're all the same color and shape, and 0 molecules because they're all by themselves. They're not touching, they're not chemically bonded. The second one, there are 4 atoms, 1, 2, 3, 4. 2 types of elements because there's green squares and blue triangles, and 2 molecules because here's 1 molecule, here's a second molecule. See if you get this one, it was tricky. 5, 4, and 2. There are 5 atoms. 1, 2, 3, 4, 5. There are 4 types of elements because there's 1, 2, 3, 4 different because these 2 are the same, but there's only 2 molecules because these have 2 touching and these have 2 touching. This is not a molecule. It is an element because it is by itself. So for hydrogen peroxide, it should be 4 atoms because you have 2 and 2 is 4. 2 elements because you have 2 symbols, and 1 molecule because we have no coefficient. And then for glucose, you should have 24 atoms because you have 6 plus 12 plus 6. 3 elements, CHO, and only 1 molecule because, again, there's no coefficient. So I could draw you a model like I've done up here. I could write the chemical formula. But no matter what, you should always be able to figure out the number of atoms, elements, and molecules. So now let's flip it around. If I give you a picture, can you write the chemical formula? So for hydrogen chloride, it's HCl. Water, you should know this one, that's easy, H2O, and we put a little 2 for a subscript because there's 2 hydrogens. 3, carbon dioxide is CO2. And 4, phosphorus pentoxide, see if you got it right, is P2O5. Well, some are asking, how do I know? What if I put O5P2? Yes, technically it's the same, but you should know that the P goes first because when I actually write it out, phosphorus is written first kind of like hydrogen and carbon are, so you know to put those letters first. Just a rule of thumb. Okay, so let's practice. How many atoms of magnesium is the chemical formula above? There's 1. And atoms of chlorine is 2. For aluminum sulfate, it is 2 aluminum and 3 sulfur. So now let's add a coefficient. 5H2. What element does the letter H represent? Hydrogen. And how many H's do you have? How many hydrogen atoms are there? Well, if there are 2 with a coefficient of 5, 5 times 2 is 10. So I've given you a list of atoms for the formula, and I want you to tell me the numbers of each atom. Okay, so what I want you to do is write the element and put an equal. So for example, on this one, and I know on your notes it doesn't have a coefficient of 2, so just pretend it does. I want you to say like C equals, H equals, and then write the number of atoms, kind of like I talked about in class, okay? So I want you to do the others on your own, okay? I want you to figure out if you can get them, especially be careful with the third one with aluminum, and I will check them Monday in class. All right, y'all have a great weekend. Bye.